Good morning, class. Here's a video to go over the 10C notes, whether we get to them today or not. If you get ahead, just want to make sure that we're ready to go. So, we had a couple logarithmic rules from our 10B notes that I would just like to go over real quick. So, if we have this first one here, log base A of B times C, what that's really going to be is going to be log base A of B plus log base A of C. Okay. So when we have two numbers multiplying in the quote unquote answer portion of the logarithm, we could split it up and add the logarithms. Likewise, if we have log base A of B divided by C, it would be the log base A of B minus the log base A of C. All right. So just sort of the same kind of rule, same kind of logic that applies when we're multiplying two numbers in the answer. We split the logarithms up and add them. If we're dividing two things within the logarithm, we'll split the logarithms up and subtract them. Notice that they have to have the same base number. Next one here, if we have log base A of B to the x power, what we can do there is we can pull that exponent up to the front, and it becomes x times log base A of B. Okay, so if we have an exponent sort of within the answer portion there, we could just pull that exponent out to the front of the log here. So x times log base A of B. There's a few fairly obvious ones here. If we have log base A of A, that's going to equal 1. Okay, because log base A of A, so we're asking for A to some power is equal to A. So obviously that power would have to be 1. All right. If we have log base A of 1, that's going to be equal to 0. Because if A to some power is equal to 1, well, the only power that would be 0. Okay. So that's that. Lastly, here, if we have log base A of B is equal to log base A of C, then we could all obviously say that B is equal to C. All right. So on these notes, we're actually going to start doing some equations that have maybe a logarithm on one side or maybe a logarithm on both sides. So I'm going to give you guys a few tips and tricks to be able to sort of solve these. And so let's come down here and talk about them. So the first thing that we have, if we could simplify one side on the calculator, which means we don't have any variables within the logarithm, what we'll do is we'll calculate this side right there, log base 4 of 88. Okay, so if we have log base 4 of 88 equals 5x plus 3, we can go to the calculator here and pull up our logarithmic function, which, okay, so log base 4 of 88. So we have 3.229. We'll call it 3.23. Call it 3.23. So here we'll have, 3.23 is equal to 5x plus 3. Okay. So if we don't have any variables in the logarithm, just calculate the logarithm out and then we could solve it. So we'll minus 3 and minus 3. So we end up with 0.23 equals 5x. There we divide by 5 and divide by 5, and we get x is equal to whatever 0.23 over 5 is. Okay. Next two examples. So if we have a variable within the logarithm what we would like to do is rewrite this thing as an exponential equation. So here we have our base is an exponent. So we have log base x of 30 equals 7. Well, we can rewrite that as x to the 7th power is equal to 30. Okay, x to the 7th power is equal to 30. From there, exponent rules. We'll take both sides of the 1/7 power. So x is going to be equal to 30 to the 1/7 power. Okay, so again, when we have a variable within the logarithm, just rewrite it as an exponential equation. If we're coming over here, log base 3 of 2x equals 4, so we know 3 to the 4th power is equal to 2x. Okay, so that would make it 81 is equal to 2x, and then x is going to be equal to 81 over 2. Go ahead and pause the video if you need to. So again, we talked about two different strategies depending on what we get. If there's no variable in the logarithm, simplify the logarithm in the calculator and just do an algebra problem. If a variable is in the logarithm thing, then just rewrite it as an exponential equation. We know how to do that from the first two sets of notes. Okay. If we have a log with the same base on two sides, so here we have log 81 of x plus 20 equals log 81 of 6x. So this is kind of the last property we talked about. So we have log 81, and we have x plus 20 and 6x. So we could take x plus 20 and make it equal to 6x. All right. So, we'll move that around. So we have 20 equals 5x, and then x equals 4 here. All right. Pretty simple stuff. Same kind of setup over here. Log base 9 of 3x squared equals log base 9 of 2x plus 1. And so we come over here, and so we'll have 3x squared is equal to 2x plus 1. This thing is going to become a quadratic equation. So because this thing becomes a quadratic equation, the way to solve that is set it equal to 0, and then we could either factor it or use a quadratic formula, or you could even, graph it if you want to. So the easiest way to do it is graph it. So if we set y equals 3x squared on one side and then y equals 2x plus 1 on the other, then we can find out what our variables are, okay? Or if you want to, we could set it equal to 0, where we have 3x squared minus 2x minus 1 equals 0, and factor it like we do all the quadratics. Again, we can go back to our quadratic notes and sort of do that as well. So hopefully we have all that copied down. We have some equations down here. So please take this time to go over solving these equations out. I will be back on Tuesday to troubleshoot anything that we may have. And I wish you nothing but the best of luck. Take care.